Hi and welcome back. We're going to finish out this lesson by talking about quadratic modeling to solve real-life problems. All right, so we're going to talk about a maximizing revenue problem. These are pretty typical, and once you get the hang of it, then it becomes a little bit easier for you. But I'm going to review the modeling problem first and have you do one on your own. So revenue is basically the amount of money that a company would get by selling a product. So the number of widgets, or in this case subscriptions, times the price that people are paying would be the amount of money that they get. So if you're selling something for $10 and you sell 10 of them, then you're going to have a revenue of 100 or 10 times 10. Right, so what we can use quadratic modeling to help us with is to figure out how to maximize revenue. And once you get into economics, you'll realize that there is a demand curve and a supply curve. And the demand curve says as the price goes down to zero, people are going to be more interested in purchasing it. So Alexa at $100,000, people are maybe not so interested, but as that price point comes down, then more people are going to be interested in buying it. The problem with reducing your price is that you reduce your profit. So ideally what you want to find is you want to maximize your profit dollars based on decreasing your price to increase the volume, but doing that in a way that each incremental decrease in price increases your profit level. So today we're just going to talk about revenue. And so there's an inverse relationship between cost and demand. So as cost goes up, demand goes down. And as cost goes down, demand goes up. So in this case, we have a monthly teen magazine. It has 48,000 subscribers. When it charges $20 per annual subscription, and then for each dollar increase in the price, the magazine is going to lose 2,000 subscribers. So at $19, actually at $21, then they're going to have 46,000 subscribers. If they decrease the price to $19, then they'd have 50,000 subscribers. So you can explain this increase-decrease in a reverse way. So for each $1 decrease, the magazine is going to gain 2,000 subscribers. So either way, it's going to work out to be the same. So the question is, how much should the magazine charge to maximize annual revenue? And we're going to use a quadratic function and the idea of a vertex and maximum minimum in order to figure this out. All right, so let me show you how this is going to work. All right, so the revenue is equal to the number of subscribers times the cost per subscription. So number of subscribers, 48,000 minus 2,000x, where x is incremental price decreases. So incremental price increases. So as I increase the cost per subscription, so 20 plus $1, so each increase in price, then the number of subscribers is going to go down incrementally. So each $1 x, I'm going to go down 2,000 subscribers times whatever that amount is. So revenue is going to be equal to number of subscribers times the cost per subscription. And now we have a quadratic function here. This is actually a function in intercept form, but we're going to rewrite it in standard form because we want to find the axis of symmetry in order to find the vertex. So that's what we're going to do. I'm going to multiply these. I'm going to FOIL. Right, first, outside, inside, last, which is a term you learned in Algebra 2. I'm going to FOIL these two factors of the quadratic. I'm going to end up with 960,000 plus 48,000x minus 40,000x minus 2,000x squared. I'm going to simplify that, write it in standard form. As we talked about before, we're going to extract or distribute out the common factors. In this case, it's 2,000. I'm left with x squared minus 4x minus 480. Then I'm going to use that to find my axis of symmetry. It's minus b, or minus 4, over 2. Right? Which brings me to x is equal to 2. So 2 is a value for X where we achieve the maximum revenue. So now I know for X, if I increase the cost per subscription to 22, then the total revenue is going to be at its maximum. All right. And so we need to figure out what that is. So we have a value for 2. Now we can figure out, here we have this maximum revenue, right? So this is really, this is number of price increases or price decreases. And we can use this as up to minus 20 because at minus 20 it's free. And we don't want that because then there would be no revenue. And then there's price increases here to 24. And after 24 price increases at $44, then no one is going to be interested in buying that subscription. And so we're looking for this point here that's the maximum revenue. So we have, I know that this value is 2, then I have to find the value for Y, which is the revenue. So I'm going to substitute 2 back into the function, and I'm going to solve, and I end up with $968,000, and which is equivalent to 44,000 subscribers times the cost per subscription of 22. Okay, so this brings us to your one classwork problem, 3.1.4. And the question is, Monthly Skateboard Magazine has 50,000 subscribers when it charges $12 per annual subscription. For each $1 increase in price, the magazine loses 2,500 subscribers. How much should the magazine charge to maximize annual revenue? And what is the maximum annual revenue? All right, so that is it for our discussion on modeling. So I just wanted to give you this one modeling question, and to be able to do this on your own. Actually, I lied. I have one more problem to review with you. So you can copy this down for the classwork problem, and then I'm going to move on and explain one more problem to you. Okay, so let's talk about dropping objects in gravity. So when an object is dropped, its height, h in feet above the ground after t seconds can be modeled by the function negative 16t squared plus h sub 0, where h sub 0 is the initial feet of the, and height in feet of the object. So the graph below shows the height of an object over time if it's dropped at 200 feet. So first it starts out slowly in terms of its speed, then it picks up speed. Over time it moves quickly in an accelerated fashion. That's the effect of gravity. So the graph shows the object dropped from a height of 200 feet. We want to write a function that models the graph, and then find and interpret h sub 1 minus h of 1 second minus h of 1.5 seconds. So how far does it travel in height? How far does it descend between 1 and 1.5 seconds? All right, so we're going to create that equation. It's negative 16t squared plus 200, right? So we substitute h sub 0 as the initial height. And then we're going to figure out what the height is at t is equal to 1 and t is equal to 1.5. So t is equal to 1, the height is 184 feet. At 1.5, it's 164 feet. So it's descended in 1/2 second, 20 feet. All right, so we've solved A by function, and then B interpreting time 1 minus time 1.5, so it's a 20-foot drop between the two. All right, so this brings us to your last, I promise this is your last classwork problem, and then we'll be done. So similar problem. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Write a function that models the path of the egg container. Find and interpret h sub 1 and h sub 1.5. And I'm going to add another question here to see if you can find out when, after how long, does the container reach the ground after it is dropped. Okay, so we're solving for h being equal to 0 when you substitute the values for h sub 0 in, and then you're going to solve for h is equal to 0. All right, that brings us to the end of this lesson. Thanks very much for joining. Really appreciate it. These are fun problems, really. I hope you find them to be enjoyable as well, and we'll see you next time for the next section, Chapter 3.